Welcome to Virtual Design Master. Today is Judgment Day for Challenge 2. This season on Virtual Design Master, we're facing another outbreak of the zombie virus. We've recruited 2 teams of virtualization professionals to lead the effort in building the infrastructure we need to move beyond the clouds. We've designed an orchestration system used to build spaceships which will be used to evacuate what's left of the human race from Earth. Thanks to Damon and Rob, we have 2 systems running across our manufacturing facilities. Most of our infrastructure uses a dual design strategy, so we can work with one of our most critical resource constraints, what's left of the human race. Our plan is to use the moon as a temporary stopover until our permanent settlement on Mars is ready. Our teams have been challenged to scale down our infrastructures to meet a number of environmental constraints. Tonight we will reveal which designs have been implemented on the moon. Now over to Eric to talk about the sponsors of Virtual Design Master.
Thank you, Melissa. It is what a show. We've had a really intense challenge set that's been put in front of us so far. We've seen some really exciting designs. We've got a lot of folks that are working here behind the scenes. As you can see in front of us, we have Team Alpha with us today here. We're going to bring on Team Beta at about 9:30. We have our judging panel, of course. We have Mr. Josh Odgers, we have Josh Atwell, and we have Mr. Brian Kirsch. Behind the scenes, Mahesh Seidel-Keesing is also helping us out, Andrea Morrow, and we also have Tom Howarth, who you may remember from the competitive panel. So Tom is actually, he's switched over because he wants to put a little herd on for the rest of the challengers, so we thought we'd let him do that from the judges panel. Of course, we have Melissa and we have Angela Luciano joining us today, so we're a pretty full house. And we have an exciting announcement. This is really cool, because not only do we have great folks that are helping to drive Virtual Design Master, we have Zerto, of course, providing our great home lab. We have VMware Press behind us. We have Veeam, HP. We have IPSpace.net or iOS Hints on Twitter. Of course, we know Ivan. We also have, to add to our list, the one and only something special, and that is Pernix Data. So Pernix Data has joined us as of yesterday as a sponsor, and they're providing an SSD drive as well as a full NFR copy of the Pernix Data FVP product. So we are very excited to bring Pernix Data on board. They are great community supporters. They've done a lot for us. They're obviously big drivers behind the VMUG community. In fact, they were just featured very recently on Tuesday at the Toronto VMUG, where Angela and I were at. So this is pretty cool. We're really excited about this opportunity to bring them on board. And this is a good time for our competitors because, in fact, we saw some Pernix Data show up in some of the early designs. So it's a good nod to what it is that they're doing with their products over there. So, Angela, I'm going to kick it over to you, and you're going to tell us all about how everybody did on Challenge 2 here, and we're going to begin our defense.
Thanks, Eric. And just before I start, I just want to add Jason Langer to the sponsorship list. A great community member, stepped up and is offering a small prize, but a prize for the winner. So thank you, Jason. Great designs, folks. A lot of detail. Surprised you were able to get them done within the short time frame. You're going to get some good feedback from our judges tonight. We're really excited about it. So I think let's just get right into it and see how each of you fared. We're going to start with Byron tonight. Byron, I'm going to give you 1 minute to talk about and defend your design, starting now.
Okay. Thanks, Angelo. So what I really wanted to work on with this design was how you handle your availability versus your capacity concerns. With only 21U, I really wanted to get as much availability in as possible, but still have as much capacity as I could. So I was kind of stuck between 3 nines and 4 nines and what to do and what that 4th nine would cost. And I ended up settling on the 3 nines for 7 hours of failure per year, and trying to get as many machines going as we could. So I think it worked out like 190 some odd VMs I could power up on it with the dual chassis UCS design, going back to some NetApp storage, the FAST 2552s, I believe, and then using vFlash to add some extra IOPS from the unused slots on the blades. So that was my thoughts.
Good stuff, Byron. Thank you. Brian, any comments, questions for Byron's design?
Hey, hey Byron. Kind of curious. You didn't specify a second virtual center. Was there a thought process with not having a redundancy piece there?
Right. So with vCenter, and this is how I usually design it. Heartbeat always was kind of terrible. Now it's been end of life, and really, I guess the best practice from VMware is to just rely on HA to kick in, and if your vCenter goes down, then it'll kick on with HA hopefully. But you shouldn't lose any functionality. You can't add anything or configure anything, but nothing else will go down. All the switching stays up, all that stuff. So that was kind of the thought there, that HA would just take care of it.
Okay, I was just more concerned with not having a second one, given the criticality, having a way to bring up even a warm one, where maybe a clone of it, something that is always available to take over the management piece, especially if you're using a virtual appliance.
Sure, no.
Because of the criticality, that was one concern I had.
Okay.
Great. Thanks, Brian.
Yep.
Josh Odgers, any comments, questions for Byron's design?
Yeah, Byron, I thought you didn't make any use of compression, which I thought might have been quite handy considering you had NetApp as well as dedupe. So I'm just wondering what your thought process was behind that, as well as your protocol choice for storage.
Sure. So the SOE choice was down to power and cooling, really, to be honest, and having as much convergence as possible to save on space with the extra fiber channel switches. I guess with the UPs you could use that as well, but that was kind of the thought there. Sorry, for your first question. Compression dedupe, right. So VCAC does flex clone natively. It's an option in VCAC you can actually deploy that way. And so I was counting on the space savings through flex clone really to take care of most of that. I thought about the dedupe part of it. Honestly, I'm an EMC guy, not a NetApp guy for my day job. So it was just one of those kind of feature set things that outside of flex clone, I wasn't just very familiar with the NetApp side of the house, to be honest.
Okay, cool.
Okay, thanks, Byron. I just wanted to add, Byron, a couple comments from Mayish. On the plus side, he liked that you had used SSDs and the flash cache idea, but do they really need to be mirrored? He wanted to know.
Well, so they don't only do the flash cache. They also have the ASXI installed locally on those drives. That was the reason for the mirror. Had I done boot for SAN, then I would have not mirrored them and just had them been both just raw drives. But because they had the OS that was there, the boot from SAN thing was kind of a coin flip for me, to be honest, and ended up going with the local because I didn't see any real benefit from doing it on a boot from SAN. And with auto deploy app with stateless, that was just kind of the thought there.
Right. Okay, great. Thank you. Thanks, Byron. That's great. We're going to go over to Damon now, and I'm going to give you 1 minute to defend your design starting now.
Okay. The key things that I were looking at is how is the base stations on the Earth going to communicate with the Moon. That was very important to me. So I described multiple ways that they can communicate in the event of any kind of eventualities through a tiered satellite system as well as a direct laser system. And I also researched different types of power redundancy on the Moon. So I have a solar array as well as an isotope thermal generator, and I described the different power systems as well. For the actual compute, I have 3 clusters. I went for a hyperconverged environment using a combination of the Cisco ISR chassis with the UCSE for high consolidation, also separation of the management from the compute, and I have redundancy in the compute. And I don't know if it was accepted or not, but I also put in a separate DR portion for the ISR in a separate part of the base station in the case that an asteroid hits.
Okay, great. I'm going to cut you off there. That's great. Good summary, Damon. Josh Odgers, any comments or questions for Damon?
Yeah, so I was a little confused about the storage design, because you mentioned vSAN as well as NetApp ONTAP Edge. So I just wanted to understand what you've done there and why you've done either of those. I'm not sure which one you did though, so if you can answer that one first.
Okay, so first I looked at vSAN as a solution for that, but because of one of the other requirements that I had, which was to have all SSDs, I actually couldn't use vSAN in the end. So I ended up going with the ONTAP Edge using the local storage as data stores. So I'd use the primary NetApp, then I'd use ONTAP Edge on local data stores for each one of the servers as other data stores. There may have been some way in order to change the way that ESXi sees the SSD, so I could see both like hard drive and SSD, but the requirements are one of each, so I couldn't use that.
Okay, cool.
Okay, great. Josh Atwell, any comments, questions for Damon?
Yeah, so Damon, I definitely wanted to say that I appreciated some of the forethought that you had as far as the communications between the lunar base and Earth and what that communication is going to look like. You know, any design with freaking lasers, with sharks with freaking lasers on their head is, well, freaking awesome. I also had the question about the vSAN, so I got to move on to something else. I thought it interesting. It felt like that you had incorporated some new technologies that I didn't recall seeing in the previous design. Can you talk about that a little bit?
I didn't really incorporate any new technology per se. It's same vendors, different product line. So that's why I used the Cisco ISR routers with the UCSE. So it's still UCS based, but you know, just a different product line.
Okay, thanks, Damon. And Mahesh had a couple comments for you, Damon. On the plus side, you laid out the requirements correctly, so he was pleased with that. And he also made mention here that you made a number of architectural and design decisions that deviated, he felt, from the original design, such as NFS instead of FCOE. So those were some of his comments on your design, but that's great. Thanks, Damon. We're going to go over to Jeff now. And Jeff, you have 1 minute to defend your design starting now.
Okay. My design, I wanted to basically come up with as much compute as I could, obviously in the 21U. I also wanted to make sure that the storage was as redundant as possible, just in case of a failure. So I know that the entire design was to, you know, obviously there was going to be some incorporation with the other segment and with our design, but I wanted to make sure that our pod, you know, the our pod was completely, you know, capable of sustaining a failure. So 2 NetApps, 9 Cisco UCS 2220 M3s, and just a couple of 5548s, all running NFS.
Great, good job, Jeff. Brian, any comments, questions for Jeff?
The Cisco that you specified, that's still the blade technology, right?
No, the C2220 M3s are 1U, 1U rack mounts.
Before that, didn't you have a blade setup?
So I originally had thought about a blade setup. So what I was originally going for was the new baby UCS that they came out with. So I was going to look at the 60, I think it's the 6325s or the 6520, whatever. I was looking at that, but I didn't want. I know that the chances of having a chassis failure on a UCS are probably about as good as getting hit by lightning, but I didn't want it to be. I didn't want that to be a point of, you know, a point of failure. So I swapped out to just single rack mounts to you know, so that I could make it a little bit easier on myself.
Now, when you did that, you also gave yourself the ability to control the power on the host a little bit more. You could always add additional power control, something from like APC or Eaton, to actually power up and down hosts depending on workloads.
Yeah, so I know that I've only seen Eaton's piece of software that they have that basically integrates in directly in with the vCenter, and you can use it to shut down and turn on hosts at will. probably I didn't. I guess I could have specified the PDUs that we were using, and if they were Eatons and so forth, then I could have basically added that into the design.
I just like the fact you have the ability to go there. You don't have that ability if you would have stuck with the blades. So I think
okay. I see what you're saying. I see what you're saying.
Yeah, that was a great decision, I think. I really like that.
Thank you.
Great, good. Thanks, Brian. Josh Atwell, any comments, questions for Jeff?
Yeah, a couple of things. I really liked how you had pointed out the environment maximums. It says this is the maximum amount of virtual machines and capacity, and how much infrastructure, what all it can serve. I thought that was a really good addition into the doc, because it gives the application developers an opportunity to understand how much floor space they have. I also liked how you identified your support of NFS because of the IPv6 constraint, and identifying your use case there. I was a little more interested in more understanding about how you were accommodating for IPv6 in your design.
The accommodation for IPv6. So I had to take into account that the VCAC appliances they didn't support it fully, right? So you still had to run a dual stack on the VCAC, so you still had to run an IPv4 section for that. And then I did some searching through the VMware storage documents, and iSCSI is definitely not supported. It's definitely in the storage documents that says it's not supported, but there was no explicit definition of NFS being not supported in there, so I went ahead and used that. And then I tried to, with my IPv6 design, I tried to only create enough networks for all of my needs, right? So with one IPv6 network, with a slash 64, it's like 18 quadrillion hosts. So I wanted to keep them, constrained down to just only the networks that I needed to accommodate the design. So I wanted to keep it as simple as possible because it's not. IPv6 is not something that everyone uses every day, so it's a little more difficult to get your head around.
Okay, great. Thanks.
Great, thanks, Jeff. Thanks, Josh. Just a couple comments from Mayesh for Jeff. He thought that you held up to the constraints that were given and managed to fulfill them. And he did have a question here. Why rack mounts?
So with the rack mounts, like I was saying before, I wanted to use the chassis, but I think the more I thought about it, the more I just didn't want the possibility of having a chassis failure. And I think with the amount of storage that I had to use and the amount of storage it would have taken to run the basically the grouping of VMs, I wanted there to be still some redundancy, and the rack mounts really serve that purpose, right? So you could basically, out of the 9, for the six rack mounts that I have for the compute layer, you could lose 3 of those 6 hosts and still run the maximum amount of groups of those servers at full capacity. So that's why I did it that way, just for basically for the word is escaping me right now. Ease.
Yeah, that's all right. Great. Good. Thanks, Jeff. Great job. We're going to move over to Joel. Joel, I'm going to give you 1 minute to defend your design, starting now.
So I wanted to really keep my infrastructure simple for the moon base. Compared to the spaceport design, I greatly increased the compute density versus specifically because of the physical space limitations, essentially doubling the compute but in half of the space. Despite the small footprint, I was able to allow for scale up and down capabilities. Down in the sense that I could shut off blades if required for power and cooling constraints, and scale up by upgrading CPU and memory capacity if power allowed. Replacing spinning disk with flash was my idea of being able to increase performance and again reduce power and cooling requirements. I stuck with the required vendors and chose to utilize Red Hat supported OpenStack for the virtualization layer and Puppet, pretty much to support automation, orchestration, and maintain compatibility with IPv6. For the networking, use static addressing for core devices and DHCP v6 for pretty much anything else.
Oh, okay, great, perfect. 1 minute on the nose, great job. Brian, any questions or comments for Joel?
Yeah, so you mentioned you stuck with Flash. If I'm correct, you had roughly about just under 200 terabytes for storage on your NetApp appliance?
That's correct, yes. 192.
192. The only concern I had is, and I hate to say this, but data never shrinks. So you didn't mention anything on like a compression, dedupe, anything like that. And 192 terabytes nowadays isn't that much. So I had a little concern that you'd actually run out of space.
So what I did there, I did calculate that based on RAID 6, I was going to be running about 188,000 or so gigabytes. What I wanted to do when I defined the maximums was work with the raw, not the raw device capacity, but I wanted to work with what I had. So in the document, I did specify that there were other compression techniques that could be used, such as deduplication. Those are sort of, in my mind, those are givens. We're going to use those, but I didn't want to bank on those and basically say, this is what I've got, and so I've got, let's say, 192 terabytes roughly, and in effect I've got a petabyte because of the following technologies. I wanted to err on the side of caution and say this is what we've got, here's our maximums. If we can do more, or we can push those limits based on compression and based on what sort of what we're able to get out of that, then that's sort of a win-win.
Okay. Thank you.
Thanks, Joel. Josh Odgers, any comments, questions for Joel?
Yeah, so on the storage choice, I might be wrong here, but my understanding is compression and dedupe is not supported on the E-series. Is that right or wrong? Or?
To be perfectly honest, if it's not supported, then that's my mistake. I didn't.
I did a quick Google and I couldn't see any support for it. I only saw explicit statements that it wasn't. So I may be wrong, but that's just what I found out briefly. So if that is correct, then I echo the same concerns that you've changed from ONTAP to E-series where you had compression and dedupe, and now you don't have it. So I kind of think you've gone down the right track with using SSD for cooling and things like that, benefits and performance obviously, but you've lost some of that feature set that would be very advantageous, as well as snapshotting and things like that from backups.
Gotcha. No, that's very good feedback. Appreciate it.
Yeah, more of a comment than a question, I guess, but yeah.
Yeah.
I guess the question I had was really the UCS chassis, albeit fairly unlikely to fail, it is a single point of failure in your solution. So how would you mitigate that?
So based on the physical, basically based on the physical constraints, I chose to use the chassis again based on the fact that the actual chassis failing was very unlikely. The best alternative I would have to that is to have an actual chassis sitting side by side. Now, that being said, to actually replace the chassis, not the easiest thing to do, so the downtime could play into a couple of hours. But I looked at that and I really thought that it was an acceptable risk based on the types of systems that it was going to be supporting. Although critical, I did feel that the downtime was permissible.
Okay.
Okay, thanks.
Good. Thanks, Josh. Just a couple comments from Mayesh. He had the same concern that Josh Odgers had, only one chassis being a single point of failure. And he has here, why did he put in KVM plus OpenStack? That's a question.
Okay, so basically what I was looking to maintain there was the orchestration and the scalability on the application side that we had talked about in the spaceport design. I didn't want to lose some of that, and because there was some questionability about VCAC and IPv6, I preferred to stick with a technology which seemed pretty clear to support IPv6, and I just didn't want to go down that road of non-compatibility.
Okay, great. Thanks, Joel. So that's
Hey,
great,
so-
guys. Sorry.
Angelo, I just wanted to say that, Joel, I'll kind of defend you a little bit on the single chassis. It does have two fexes, right? So I mean, you got some redundancy in there.
Well, the whole got redundancy built in it. You're right.
Yeah.
Thanks.
Thanks. Yeah, so thanks, guys. Great job this round. I know you guys put in a lot of effort. Hoping that folks follow on Twitter the hashtag Virtual Design Master, because there's a great conversation going just within the community. Participants asking other participants, for help, for comments, even folks just throwing out questions in general. So it's a great way to engage with the participants as they work through the challenges. So I encourage folks to follow hashtag Virtual Design Master. So with that, I'm going to give it back to Eric.
All right. Well, what we're going to do now, of course, we've hit the halfway point. So congratulations, Team Alpha. You've done a great job with the designs. We know it's a challenge, so we're going to ask you, if you don't mind ejecting and clearing the deck, then we're going to bring on our second group here. One of the cool things about what we're doing here at Virtual Design Master as well is, we've engaged a great community. As Angela says, just following the hashtag Virtual Design Master alone will tell you the kind of, the kind of depth of conversations that are happening out in the Twitterverse and through other means. Google Plus. There's lots of people chatting on there. It's been a great opportunity to see people interact and almost a sort of co-opetition going on. As well as what's going on there is we also ran a recent prize campaign, and this was for an opportunity for 2 lucky folks to be able to win a 1-year subscription, or at least to the remainder of 2014 for ipspace.net. This is Ivan's great webinars, and he's got anything that you need to become a virtual design master. Ivan's content covers a lot of really amazing high-level networking designs, where lots of work on overlays, advanced networking, and advanced computing, and high availability work. So we're very proud that Ivan has jumped on board and helped to support us. And we're going to tweet out a little bit later, but we wanted to announce live here that Lee Koshin, he's at backup_guy on Twitter, as well as Brian Trainor, he's at BE-Trainor, that's Trainor, are both the winners of our ipspace.net competition. So congratulations to you folks. We're very proud to be able to offer that. And again, thank you very much to Ivan for that. We're glad to have him on board. Now we're going to bring on our Team Beta folks here. And one of the interesting constraints that we applied, and we really tested a lot of folks with this, and that was the addition of IPv6. Now, granted, it may seem like it's a far-out concept to adapt to IPv6, but again, as a virtual design master, this is exactly the kind of thing that you're going to have to face when you're looking at large-scale environments. And going forward, it's not necessarily what you're doing today, it's what's happening tomorrow. As a virtual design master, it's very important and absolutely key that you have your ear to the ground on technology and you know what's coming next. If you look at our panel of people that are judging here, that's exactly what put them into the position that they're in. It's because they've had a real, advanced, large-scale view, regardless of the environment that you're deploying into. It's good to have that bigger vision. So, welcome aboard. We have ourselves Rob Nelson, Timothy Patterson, and Sean Massey. We're missing Alex at the moment because he was unable to attend, but we would like to welcome back Team Beta. Now, of course, in this case, we had Rob, and Rob was the creator of one of the designs that was used for the competitive team. So Rob had the distinct disadvantage, of course, that he was using Damon's design here. So not only was everybody unfamiliar, but he knew that his design was getting used by another team. So you actually you did a lot of great work, and in fact, we did have great comments from the other competitors on the great work that happened from your design. So, Angelo, why don't you walk us through, and let's get our defenses started for Team Beta.
Great, thanks, Eric. And congratulations, everyone. Great designs. As I mentioned earlier to Team Alpha, I know it's a lot of work in such a short time period, and you guys pulled it off, so congratulations there. So we're going to start with Rob. And Rob, I'm going to give you 1 minute to defend your design starting now.
All right, my design was to try and take Damon's design, scale it down quite a bit, leave some room for growth, some room for expansion in the rack systems itself. And where IPv6 was concerned, I think I took a very conservative look with trying to find compliance statements. There actually weren't a lot out there. So if there was no compliance statement, if it didn't mention it at all, I assumed that it wasn't compatible. I also searched quite a few non-standard places, called some SEs, and found a lot of the products there were not actually IPv6 compatible. So what I did was I tried to take the remaining products that were there, put it together, make it a reliable system that if the teams got cut in half, could still be supported without a lot of complexity, and also have some redundancy in the chassis, things like the spacing in the rack to make sure component failures didn't cause cascading failures.
Good. Great job, Rob. Josh Odgers, any questions, comments for Rob?
I guess the first comment, and I apologize if it's a lot of noise on my line now that I've turned my microphone boost up due to a complaint on Twitter. So what I found really good in your updated design was you went back and you addressed the previous design decisions and you updated them. So I thought that was great. So big round of applause for that.
Thank you.
The use of rack mounts, I'm quite interested to hear, especially after Mr. Atwell's comments on Twitter, why you went with rack mounts.
I went with rack mounts for two reasons. One is the risk of a chassis failure. We don't know how long we're going to be living in the moon base. If this turns out to be a 4, 5, 6 year system, then maybe we do start to run into issues where it's not a lightning strike. It actually is something we could predict. With the rack mount servers, we have a little more granularity. We don't lose quite as much when we have a component failure, and we could also scale up a little bit if we acquire some more hardware without outrunning the 21U.
Cool, and yeah, take that, UCS people.
That was a great answer. I'll give him that. That was a fantastic answer.
That was good,
Beautiful response.
Yeah, I was just going to also say that you're still leveraging data protection, VMware data protection, when you've got a NetApp solution underneath. So I think that is probably constraining your storage capacity a bit, because you're not going to be able to leverage your compression and dedupe that you have natively with the NetApp solution. So you're capacity constrained as a result.
Yeah, it is capacity constrained. As I mentioned last time, I'm not very familiar with the NetApp, and trying to get a handle on all the IPv6 didn't leave a lot of time for me to try and get a good handle on that. I learned a little bit about how to use the SVM, the vServers, to handle some of the management better, but the snapshot stuff, yeah, I definitely would have loved to get some more of that in there.
Cool.
Good, great. Great, and it sounds like, Rob, that one of the goals of the Virtual Design Master is that you actually are learning while you're progressing through the competition. So it sounds like you're doing that. So that's fantastic. That's great. Josh Atwell, any questions, comments for Rob's design?
Yeah, so I'm always a fan of finding the little Easter eggs in the designs. I love the infinite creativity. So the use of dude, I thoroughly appreciated that. Thank you for that. And, I had two thoughts, and one is a general thought, and I'll save that for after you answer this question. If you had to choose between adding more storage or more compute with your design, which would you go with?
I think the storage is low, but not knowing where the workload is, it was really tough to kind of make a decision to commit either way. The storage we know is low. The compute, I think we could probably get away with a lot less. A lot of applications these days are really constrained by memory and transport and storage more than they are by the compute itself. So I'd probably lean towards that, but it would be nice to know more about how the workload's actually going to turn out.
Okay. Yeah, and you're not the only one. A couple of people have made mention about maintaining room for expansion. And in most situations, I think that's apropos, right? To always be prepared for expansion. However, I almost question whether expansion is needed in this scenario, given that the moon is supposed to be a temporary jumping point, and we have a finite number of remaining humans, right? Zed has pretty much wiped a lot of people out. It kind of left me as I was reading this. I'm like, do we really need additional expansion capabilities, or will the 21U suffice?
Perhaps not. Something that you could use the expansion room for is if you did lose the other support team, you'd really only have one system to run maybe you could cannibalize some hardware from the other system.
Fair enough. But just a thought for people listening at home.
Yeah, great.
I just want to congratulate Josh on the first use of the word apropos at the Virtual Design Master.
Congratulations.
We're all up.
Despite my general jovial nature, I am fairly well read.
There you go.
Okay,
Rob,
great.
one little additional piece. I noticed you left your servers at 512 meg of memory.
Yeah, I wasn't going to say anything about that.
I think you meant to have gig. Not a big deal. Just something kind of that jumped out at me. I stopped when I read that.
I thought the 1U servers I chose only went up to 512. I thought 2U servers were 1 terabyte.
No. You had a typo.
You had a typo.
Did I say M?
Megabyte.
I got you. All right.
We knew what you meant.
That's great. Good.
You've
Thanks,
got
guys.
great benefits from transparent page sharing is all I saw in that design, so that's fine.
Great. Good insights, guys. Great. And from Maya, she had a couple comments. On the plus side, he liked the delta comparison of the design decision, taking into account the constraints, and the use of VCO and Puppet. He liked the workflow description. So those were his comments. So great job, Rob. So we're going to go over to Sean now. And Sean, I'm going to give you 1 minute to defend your design starting now.
All right, so first off, can everybody hear me? I muted myself last week.
Oh, you're good.
We're all good.
Okay. So, I tried to keep to the spirit of the design as much as I could, tried to keep the components as similar as possible to what was done with the design in round 1. This was my first go-around with NetApp as a storage appliance, and I have a little bit of experience with UCS, but not really that much. My goals here were to try to avoid single points of failure as much as possible while keeping density for both storage and compute, keeping them as dense as possible to get the most out of that rack space. I also want to point out quickly there is one mistake in the design that I did not catch before I turned it in. I used 6324 fabricate interconnects on the back. I designed it for, initially the compute nodes were designed with 10 gig ports off the back, but those only support 4 in pairs. So that is a mistake in the design, and I caught that, but it was too late to fix it.
Great. I'm cutting you off there. That's okay, Sean. That's great. Brian, any comments, questions for Sean?
Hey, Sean. I loved your first design with the rack mount. I thought that was real solid, and I thought that was a great use. I was kind of curious why you went to blades, specifically also Cisco. What was the logic behind that?
Well, first off, one of the requirements in the design was that we had to continue to use the same vendors from the previous round. Damon's infrastructure was all NetApp and all Cisco. The reason for going to blades was when I looked at the space use, going with rack mount, even at 1U, I could get 8. To get the same density, I would have to use 8U to get what I could get in 6U with the UCS chassis. So by shrinking down to blades, I was able to get more for less.
Okay.
Great. Josh Atwell, any comments, questions for Sean?
Always, absolutely. Two things to note. One I'm going to note is that you had all those blades but no management cluster, which made me a little sad panda. I think that is a definite oversight, and don't do it again. Bad. But I'm going to kind of challenge you because on one thing with this design, IPv6 was really, really important. Talk to me a little bit about you specifically. Nice. Yeah. He also agrees management cluster missing is a bad thing. You mentioned the use of VC ops for management and long-term management. Talk to me about IPv6 support with VC ops.
I wasn't able to find anything in particular about using IPv6 with VC ops in the searching that I did within the documentation and support. what I did in the design, I realized IPv6 was important, but because there are a number of pieces within the VMware stack that don't support IPv6, and the hypervisor layer was VMware, there is an unrouted IPv4 private subnet on that management VLAN as well. Be able to access that from the rest of the IPv6 network, you would have to remote to some sort of jump box to get access to manage those items. Unfortunately, like I said, I couldn't find anything one way or another to say this was supported. So I had to use that kind of as a hack to get around it.
No, I mean, that's completely fair. I mean, you at least address the fact that there was a known potential gap and a way to work around that to maintain compliance. So, okay, good deal. Thank you.
Good, thanks, Josh. Mayish had some comments for you, Sean. On the minus, still used IPv4 traffic in addition to IPv6, and on the plus side, the memory mirroring in the blades on the plus side. So that's great, Sean. You're off the hot seat now. So
thank you.
Great. So we're going to go over to Timothy. And Timothy, I'm going to give you 1 minute to defend your design starting now.
All right, sounds good. Hopefully everybody can hear me. I'm in the middle of nowhere. My design, I tried to maximize the 21U as much as possible. I eliminated all of the NetApp. I went with Cisco C-Series rack mount servers, loaded them with local disk, local SSD, run vSAN in the environment, and basically just tried to isolate single points of failure as much as possible. I figured that by keeping the design short and simple, it's the best way to go. I just couldn't figure out a good way to get the blades in there without a single point of failure, and by going rack mount, you can upgrade one host at a time in the future.
Okay, great. Good job. Josh Odgers, comments, questions for Timothy?
Yeah, look, I think the choice to go to vSAN, I can certainly see your logic behind that. Trying to reduce some complexity there. I don't know if we've technically broken a rule there by introducing a new technology, but let's assume we haven't. So you've deployed vSAN to the moon, and that's different to your deployment on Earth. So my question there is, you've essentially doubled the storage technologies in use in your overall environment. So is that an operational or a complexity issue that you need to deal with? And how have you dealt with backups, being that you've got two different environments?
Right. Well, I guess my point there was the storyline was a little unclear. I kind of was operating under the assumption that the Earth was left behind for the moon base, so that we were just trying to maintain the applications, make sure everything continued to run, as the moon was a temporary jumping point until we get to our permanent home on Mars. So that's the approach I took. Yeah, I can see what you're saying. Operationally, that would be another complexity that would have to be addressed in operating guides and staff training and everything. But like I said, I was operating under a different assumption regarding the storyline.
Sure. And the other point there was just around backups. How are you going to handle that on the moon?
Right. Well, backups really were not addressed in the design. They were, availability was first and foremost. So make sure that everything is always available, no chance of failure throughout the design. As far as error proofing procedurally, I made sure that like a dev and test environment actually ran off of nested ESXi and used the UCS emulator inside of the environment to do the testing and whatnot before things made it to production. So I didn't specifically address backups, but I addressed the operational procedures to make sure that data was okay at all times and built in the redundancy.
Okay, great. Brian, comments, questions for Timothy?
Okay, two comments. You specified the original system vols at 50 gig. I think that's going to be a little light, given it's Microsoft, and we all know where that goes. So I had a little concern there. And the removal of the management cluster.
Right.
That to me hurt. That...
Bad, bad.
Let's just say that's something I wouldn't normally do. I was just trying to live within the constraints of the overall scenario. A management cluster is definitely key. And I really feel that that's kind of why I also integrated the dev and test environment into a nested ESXi field, just so they can play and not blow anything up. Yeah, I agree. A standard design should have a management cluster, but then again, I mean, this is only a temporary landing spot on the moon, so that's why I didn't address that.
Okay, thank you.
Okay, great. And Timothy Mayesh had a couple comments here. Because of vSAN, he chose rack mounts plus flash as a plus, and as a minus, adding 5 pages of marketing about the Cisco C240M3. Maybe we could have handled that a little differently. So, anyways,
Sure.
that's great. Sorry?
Just trying to pass along the max configuration specs and operating variables there, especially around the environmentals. I addressed the power draw and the physical characteristics of the machines.
Great, good. Okay, thanks, Timothy. Thanks, everyone. Great work again. I know, again, the time frame is short, and you really pulled off a design within that period, so that's great. So with that, I'm going to throw it back to Eric.
All right. Well, this is the time that everybody waits for. But there's an interesting twist. We're all about twists. What we start today is not only do we have the unfortunate task of having to send a few folks home, but in fact we want to bring somebody up to the top. During the first design, we kind of saw a bit of that already happen. We saw designs that moved forward that were used for the base documents for the 2 teams. And those came from Damon and from Rob. So that was great work on both your parts. As we headed into Challenge 2, we were really excited by the work that happened, not only in reproducing a new design based on extreme constraints, but in one particular case, somebody stood out, not only having had a great design in the first challenge, but being able to take an opposing design and actually make that work with great detail and a lot of good information there. And so for that, we would like to thank Rob Nelson. And Rob, you are the proud winner of the $100 Amazon gift certificate from Jason Langer at virtuallanger.com. So Jason is a very good community supporter, and we're very proud to have him on board. And he sends his best, obviously. So all of the judges made great notes. Everybody had great designs, and we were particularly proud of the work that you did. Again, through Challenge 1 and Challenge 2, it really showed up well with the detail that you're able to give.
Wow, thank you.
So that brings us to the next point, which is where, unfortunately, we have to clear the deck of a couple of folks as we head into the next challenge. And I'm going to turn it back over to Angelo to deliver the news.
I think this time around, I'm actually going to throw it back to Eric to deliver the news.
But Angela, you do so good at this part. I really would love to turn it over to you to tell everybody who unfortunately won't be able to join us in Challenge 3.
Right. Okay. Okay. Fine. All right.
Poor Angelo.
Yeah. Thanks, Josh. Thanks. Everyone had great designs. I really want to stress that the designs were great. I do want to put a disclaimer out for folks watching the Virtual Design Master. These designs are great, but they're not tested in production. So please don't deploy these designs in production.
Don't try this at home. Well,
Yeah.
try it at home, but not at work.
Right. So that's just a small disclaimer. So now that we have that out of the way, the judges have decided, and Alex, Joel, and Sean will not continue in the competition.
Now, we had a very interesting situation again that popped up. We did have Alex was unable to join us for a couple of reasons. Obviously, tonight he wasn't here. He actually had some time challenges, and he was unable to complete his submission. So, in fact, based on that, we're going to say that somebody got a free ride into challenge number 3. That being said, again, it's a difficult time. No one wants to say that designs aren't good, but that's not what we're saying. What we're saying is that you're up against a field of incredible competitors, and we have a really, really distinct high-level set of criteria, and you've been given a really wild set of requirements and constraints to work with. So again, although we won't be able to bring some of our folks back into Challenge 3, we wanted to thank you for the great work that's been done so far. We're going to publish your documents again. So these were great designs, and it's not to detract from what's happened. We're very proud to have everybody on board. And of course, we talk about Challenge 3, and I think Melissa's going to tell us exactly what our team is Challenge 3. Now, one thing is there are no longer going to be Team Alpha and Team Beta. We're centralizing now, as we only have 5 competitors moving forward, that we're going to have a smaller group. And so they're actually going to be all solidified, and there's not going to be any teams involved. So Melissa, let's talk about challenge number 3.
Challenge 3. Spaceship depots continue to come online, with launches to the moon occurring daily. The moon bases have been stabilized, and humans are beginning to settle in. Not surprisingly, many island nations fared better than expected during the outbreak. Their isolation could be very valuable if we face a 3rd round of infection before the Earth has been evacuated. We need to get them back on the grid as soon as possible. Japan, Madagascar, and Iceland are first on the list for building infrastructures. Local teams have managed to get some equipment, but all you'll have to start with is one repository and blank hardware. As we've learned while building the depots, travel is dangerous and difficult. You will need to create your infrastructure in a lab first to ensure it will be able to be quickly deployed by a local team. Once the process has been deemed successful, we will establish a satellite link to the islands to get everything we need to the local repositories. You must create an infrastructure from scratch using a VMware cluster including shared storage, HA, and DRS. It also must be powered by OpenStack. Deployment of instances will be done using the OpenStack Horizon dashboard only. Any version of OpenStack networking may be used. Obviously, there are bonus points for those who may choose to deploy an overlay network, such as OVS and Neutron. The VM images will include 1 Linux and 1 Windows instance. Any version or distribution will be allowed. DevStack cannot be used. In order to remove single points of failure due to the availability of human resources, you must integrate a second hypervisor of your choice. You must have 2 VM images hosted by this hypervisor, 1 Linux, 1 Windows. You must document your topology and provide visual proof of working deployments using video. Designs will be submitted in PDF format, including diagrams and all supporting documentation. Your design should speak for itself, and your defense will support it with defense questions from the judges. So that's challenge 3, guys, and challenge 3 is called Stacking the Odds.
So we've this one's kind of near and dear to my heart. I'm very proud to see OpenStack making its foray into the Virtual Design Master. Of course, we've seen it in some of the early designs. We know this is going to be a very interesting challenge. We know the integration of VMware and OpenStack is a very key thing as we head into sort of the next generation of cloud computing and even on-premises private clouds. So while this may seem like a bit of a wild reach in many data centers today, it's something that's going to be coming. So we're very excited. Now we understand this is going to be a much more difficult challenge than some of the previous. For any folks that are going to have any difficulty with getting the video recording, you can reach out to us back at the Creative Design team, and we will help you out with any of the tools that you need in order to do your recordings, as well as any help you're going to need for lab hosting. So we head into Challenge 3, and we are stacking the odds against our competitors. Thank you, everybody, again. Thank you to Team Alpha, to Team Beta. Again, for our competitors that aren't going to be able to continue to carry forward, Joel, Sean, and Alex, we're sorry to see you guys go. But who knows? We'll have lots of other opportunities to chat through it the rest of the competition. So on behalf of myself and Angelo, Melissa, Jonathan, who's very kindly sitting in the background, he's waiting because just wait to get to Challenge 4. He's going to make your life difficult. And of course, on behalf of all of our judges today, we want to thank you for watching the Virtual Design Master, and good luck with Challenge number 3.